So here's a run through for the y equals x squared family worksheet. I think it's called Introduction to Quadratics on the actual title of it. So I talked through this a little bit already, but I'm going to actually go through it and do the problems and write them out and stuff. So the first question says, consider the functions f of x. So it has all those functions there. List the functions whose graphs have a maximum at the vertex and those that have a minimum at the vertex. So the idea is we're just looking at whether they've been reflected across the x-axis or not. And we can tell that completely by whether a is negative or positive. So if I wanted to say the ones that have a maximum are ones that have not been, or that have been reflected, because they would be upside down. A normal parabola looks like this. A reflected parabola looks like this. So you can say this one has a minimum, this one has a maximum. So the maximum ones would be all the ones with negative a's. So the maximums would be g of x and k of x. We're really not looking at anything else except for that number up front, the a. So remember in vertex form, which these are all in, you have y equals a times x minus h squared plus k. And really we're just focused on the a. And so the ones that have a minimum would be the ones that are right side up parabolas, if you will. That would be f of x and h of x. Part B says list functions is from widest to narrowest, or as their graphs would appear on a coordinate plane. So again, what makes them wider or narrow is that stretch factor. If this is greater, that means everything's going to be lifted up taller, which will have the effect of making the parabola more narrow, because this point has been lifted up to there, this point's been lifted up to here, etc. So the bigger the number, the narrower the graph. The smaller the number, the wider the graph. So we're going to go from widest to narrowest, so that'd be the smallest number. So I'd start with k, and then the next one would be f, and then g, and then h. I'm going to change that color real quick. Okay, given the vertex of a parabola and a second point on the parabola, find the coordinates of a third point on the parabola. So this is completely based on the idea of symmetry. So we know the parabola normally looks like this. Since the vertex is at 1, 1, that's what this is telling us. So that means this is saying if I go from there over 2, up 3, I should hit another point, or I hit a point on the graph. So the idea is I need something on the opposite end of that. So the other point is going to have the y-coordinate of 4, because the point of symmetry for that point would have the same y-coordinate. And the x-coordinate should be the same distance from the x-coordinate of the vertex. So notice that this is 2 over from the vertex. That means the other one would be 2 the other way. So this would be -1. Part B, so we do the same thing again here, going over. So I know my point's going to be 11 as my y-coordinate. And since this is 7 to the left of the vertex, I got to go 7 to the right, so 4 plus 7 would be 11. So I went ahead and finished off that third one off the camera. So number 3 says the ball is thrown downward at a speed of 10 meters per second. So since we're in meters, the height, we can write a formula for this. That would be -4.9 t squared. And we're throwing it downward, so it's going the same direction as gravity, so that'd be -10 t plus 50. That would be the equation I'm going to use. So when it says find the height of the ball 2 seconds after it's thrown, that would be h of 2. So I'm just going to plug h of 2. I'm going to plug 2 into that equation. So when I plug in 2 into that equation, I end up with 10.4. Likewise, this is how long it will take the ball to reach the ground. Now, in this case, I'm looking for height to be 0. So I'd set my equation equal to 0. So I have this negative 4.9 t squared minus 10t plus 50. And I would solve that equation. So now to solve this equation, it's not factorable. And the way we solve quadratic equations is either by factoring or the quadratic formula, or completing the square. There's a few others, but in this case, just throw in the quadratic formula and it'll produce two answers. One of them negative, which doesn't make sense in the context. So, and the other one is approximately 2.3. So we come up with an answer of t is approximately equal to 2.3. Okay, number 4, a tennis ball at initial height of 2 meters is hit upward with initial velocity of 40 meters per second. So again, the formula is going to be h of t is equal to negative 4.9 t squared plus 40t plus 2. It's a positive 40 because the velocity is going up, which is in a different direction than the gravity is pulling it. So part A says, what is the maximum height of the ball will reach? So that essentially is the y-coordinate of the vertex, right? Because this is a negative parabola, or negative a, which means it's an upside down parabola, so it will have a maximum, and that maximum occurs at the vertex. So I'm going to have to plug in, one way to do this would be to go x equals negative b over 2a and solve that, which gives you what, about negative 40 divided by negative 9.8, which is equal to, which is about 4.1. And that, of course, that's when it reaches maximum height. So that's not the answer we're looking for. So we plug that back into the equation and we end up with about 86 point, I'm sorry, nope, that's not right. 83.6 meters. Okay, that would be my answer there. Part B says, how long will the ball be in the air? That's a question of when will the height get back to 0? Because when the height gets to 0, that means the ball isn't in the air anymore. So we're going to solve this equation by setting it equal to 0. So it'd be 0 equals negative 4.9 t squared plus 40t plus 2. And we'd solve that again using the quadratic formula. And we get two answers, a negative and a positive. And the negative one we throw out because it doesn't make any sense. That would be before time began. And the second one is t is about 7.37 seconds. And finally, find the height of the ball 3 seconds after it's hit. That's merely just plugging 3 into the equation. And if you do that, calculate, you end up with 77.9 meters. Notice that is pretty close to the maximum, which shouldn't be surprising because we're only a second away from reaching the maximum, approximately. So that's kind of makes sense there. All right, moving right along. Anna kicks the ball in the air. After 0.1 seconds, the ball is 10 feet above the ground. After 1.3 seconds, it reaches the maximum. So picture here, what we're doing is they're telling you something there and there-ish. And at what time will the ball be at a height of 10 feet on its descent? So they're really asking you for how long does it take to get over here, because we're looking for a reflection image of that guy across the line of symmetry. And since this distance here, or this time difference here is 1.2, then we want the same time difference over here. So that would be 1.3 is where the vertex is. So we'd add 1.2 to that, and we get 2.5. And so what time will the ball be at the height of 10 feet again? It would be 2.5 seconds. In other words, because of symmetry, it takes the same amount of time to go from here to there as it does to go from here to there. Given each pair of reflection image points on a parabola, find the equation of the line of symmetry. So we know that if these are reflection images, that the line of symmetry has to be exactly half in between them. And the way you write the equation of a horizontal or a vertical line is x equals. So we're just looking for the x-coordinate between those two. See, from 3 to -1, that's 4, so it'd be 2. So it would be 1, x equals 1. And halfway between 25 and -3, that would be a total of 28. So it'd be 14. -3 plus 14 would be 11. And that goes from -4. Oh, that would be easy. That's just x equals 0, isn't it? Nice. All right, number 7, write the equation for each of the following parabolas described below. So we're looking for, really we're keeping in mind this equation, y equals a times x minus h squared plus k. And of course the vertex provides the h and k for us, so we know that this is y equals something times x minus 3 squared plus 4. I do a minus 3 because this has been moved to the right 3 from the normal vertex, and a plus 4 because it's been moved up 4. And so then we just got to figure out whether this is a normal shaped parabola or not. And you notice if you go from 3, 4 to 4, 5, that would be over 1, up 1, which is the normal shape of a parabola. So that means I don't need an a. The a is just 1. So that's my equation. Now you notice on this one, this is just going to be y equals, now this will just be x squared with no shifting, right? Because the vertex is where it's supposed to be. So there's no plus, the h's and the h and k are both 0. But notice, however, from here, if I go over 1, up 1, I don't hit the graph. So that means this graph has been stretched. And we notice that if I normally go over 1, up 1, I hit the graph. This time I go over 1, up 3. That means that point has been stretched 3 times as far away. So that means there's a vertical stretch factor of 3. And of course, we would do something similar to that on all of these. And I'm going to pause the video and do those, and then you'll see them in a minute. So I filled in the rest of those equations. Notice on the negatives, we notice that from 3, 0 to 2, -1, it's going, the x's are going down 1 and the y's are going down 1. So that tells me that it's an upside down parabola, so it had to be reflected. But I put a 1 in there because it's the normal shape. Notice I didn't put a 1 in here just to show that either one would work. You could put -1 or just negative. They both mean the same thing. But this is also upside down parabola. This one here, you would normally, looking at f, normally you would go over 2, up 4. That's the normal shape parabola. So this one over 2, up 2, that means it's half as tall as it's supposed to be, or compared to the parent. So I wrote a 1/2 stretch factor out front, vertical stretch factor. Okay, and finally, for each of the following equations, using the shortcut method we just learned in class, describe how you know what the graph looks like, and then sketch its graph. The shortcut method is just the whole transformation process. So each of the so this thing is going to be vertically stretched by a factor of 3. Everything else is the same. This thing is going to be shifted, or actually maybe even, I don't have to use all that language because we could just say the vertex is at 2, 2, and it's a normal shaped parabola. This one, the vertex is at -1, 0, and it's upside down because of that negative, and it's stretched vertically by 2. Okay, this one is upside down and compressed vertically. Oh yeah, I said I wasn't going to use the word compressed. It is stretched. Whoops. it is stretched vertically by 1/2, which means it's really compressed. And this one is upside down again because of that negative. And the vertex is at the point 3, 5. Yay. And last but not least, upside down. And the vertex is located at 0, 3.